So this is the continuation of module number 1, lecture 3, which is this is lecture number 4 about soil and geology. We will be discussing strike and dip and up to the earthquakes and some of the different types of movement of soil. No? So strike and dip refers to the orientation or attitude of a geological feature. The strike line of a bed, fault, or other planar features is a line representing the intersection of that feature with the horizontal plane. On a geologic map, this represents with a short straight line segment. A strike can be given as either a quadrant compass bearing of a strike line in terms of east or west, of true north or south oriented parallel to the strike line. So as you can see, this is the orientation of a strike line. No, so it is oriented on the east-west. So this is the north south dip direction. So this will be the possible erosion or event that may occur, no, on the particular site, or the possible formation of underground layers of soil, no, of the soil on that particular site. The dip gives the steep angle or descent to the bed or feature relative to the horizontal plane. One technique is always to take the strike so that the dip is 90 degrees to the right of the strike. The angle of the dip is generally included on geological map without a degree sign. So this is the what you call the dip. No, this is usually seen on as you can see the strike. No, this is the strike which is along the east-west direction, and this is the direction of the dip. No, which is possibly going to the body of water. So this is the angle of the dip under the elevation or the natural inclination of the ground or the water. So this is in relation to the angle of the natural inclination of the water. So that is called the dip. So in formation of the soil, we also have what we call the folds. So folds are one of the most common geological structures found in rocks. When a set of horizontal layers are subjected to compressive forces, they bend either upward or downward. The bends noticed in rocks are called folds. Folds are described variously in wavy or arc or curved or warping appearance found on rock. So these are samples of folds on rocks. This is what the sample is called the we will now describe this as the anticline, and the cline is the inclination. The anticline is the opposite, and the cline is the inclination. So when the beds are bent upwards, a resulting fold is called the anticline. So this, when the bend is resulting upward, it is called the anticline. This fold is a convex upward. Okay, so these are called the anticlines. No? And the clines are the inclination. So these are the inclination, and this totality of this curve or the fold is called the anticline. Okay. So the syncline, the syncline is the opposite of the anticline in stature. When the beds are bent downward, the folding fold is called the syncline. The fold is a convex downward. So these are the syncline. So these are the anticline, and these are the syncline. So okay, some areas have those multiple folds. No, this is called the anticline, and these are the syncline. No? And this folding, they are commonly symmetrical. No, when the axial plane divides into fold into two equal halves in such a way that one half is the nature image of another, then such fold is called the symmetrical fold. No? So these are the syncline, these are the anticline, and it is a regular equal wave, and these are called symmetrical folds. The asymmetrical folds, if the two halves are not in the mirror image, like this one, no, if these are not in the mirror image, like in this one, in this case, it's inclined. So this one is called the asymmetrical folds. So we have different types of folds. We have the symmetrical, the asymmetrical. This is not a good figure, no? So the open folds on the intensity of the formation of the beds of the folds may vary, may or may not have uniform thickness. If the thickness of the bed is uniform throughout the fold, it is called an open fold. So if the thickness of the folds are uniform, it is called an open fold. Okay? If the folds are not uniform, it is called a closed fold. Closed folds. So if it is not uniform. Okay? So uniform folds, it's called open folds, and the irregular, uneven thickness of folds, it is called a closed folds. Faults is a structure or zone of fractures between two blocks of rock. We often hear this term. Usually, if there are earthquakes, the news always refer the earthquake movement and relate it to the nearest fault line. The faults around allows the blocks to move relatively to each other. This movement may occur rapidly in the form of an earthquake. So the faults may move rapidly if there will be an earthquake, or move slowly in a form of creep. Fault may range in length for a few millimeters or thousands of kilometers. So faults may have a range of or length from few millimeters to thousands of kilometers. In the Philippines, we have the Marikina fault line that runs from Bulacan up to Laguna. So during an earthquake, the rock or one side of the fault suddenly slips with respect to the other. So this is a sample of a normal fault. This is the fault line. And then one side of the fault slips, in relation to the other side of the area of the fault. So if you have a house on top of the fault line, your house will eventually break, because of the movement of the fault line. So causes of faulting may occur in regions or structural instability. It may be recollected that faults develop mainly due to a shear or sliding failures of resulting from tensional and or compressional forces. When an earthquake occurs on one of these faults, the rock on the one side of the fault slips with respect to the other. Fault scrap. So you can see this is the sample of a fault line movement. So the soil that was exposed during the movement of the fault line is called the fault scrap, and there is a line that will be shown after the movement of the fault line, which is called the fault trace. And then they will calculate the epicenter or the epicenter of the movement of the fault plane, and then they will study the different the effect of the fault movement to the adjoining areas of this site. So the fault plane is the plane along which the adjacent blocks are relatively displaced. This is the fault plane. And then in the other words, this is the fracture surface on either side of which the rock has moved past one another. So these are the fault planes. This is the plane that has moved, and this line is called the fault strike. Okay, this line is the fault strike, and this particular line this is called the fault trace. So So when fault plane is inclined, the block which lies below the fault plane is called the foot wall. Okay, the other wall which rests above the fault plane is called the hanging wall. So this is called the foot wall, and the part of the fault line that moves downward, it's called the hanging wall. Okay, so in displacement, this is the slip is the displacement that occurs during faulting. This is called the slip. The total displacement is known as the net slip. This may be along the strike direction or the dip direction. This one is called the reverse fault. This one is called the normal fault, and this one is called the strike slip fault. So it's very dangerous to construct something on top of the fault line. So there are regulations that can be seen on the PhilVox, Philippine Volcanological Agency, that requires us to move away from the fault line. No? So I think it's about 100 meters or 50 meters away from the fault line. So that is the recommended recommended distance away from the fault line. But there are also limitations on how high the buildings can be erected along or very near the fault line. So if you will be building something very near the fault line, you need to address the movement of the soil, the possible movement of the soil, no? During an earthquake. So before an earthquake, this is the fault line, no? These are the tectonic plates, no? And these are the fault line. And after an earthquake, tectonic plates slides, no, each other, and then you can see that there is a slip or a dip, no, on this fault line. And this the planar, the planes are separated from each other. So parts of a fault, no, we have the heave and the throw. The horizontal component of displacement is called the heave, and the vertical component of displacement is called the throw. In vertical faults, there is only throw but no heave. In horizontal fault, there is only heave but no throw. So this is a sample of a movement of a fault line. So this is, as we have discussed before, this is the fault planes, no? This is the hanging wall, and this is called the heave, no? The heave is this direct the movement of the heave is the horizontal displacement, and the vertical displacement is called the throw. Okay, so this is the horizontal displacement, it's called the heave, and the vertical displacement is called the throw. Okay, so heave and throw. So earthquakes are sudden violent shaking of ground, typically causing great destruction as a result of movement within the earth crust or volcanic action. A sudden release of energy in the earth crust or upper mantle usually causes by movement along the fault plane or by volcanic activity, and resulting in the generation of seismic wave, which can be destructive. Seismic waves are waves of energy that travel through the earth layer, and are a result of an earthquake, explosion, or volcano that gives out low-frequency acoustic energy. Seismic waves are studied by geophysicists called seismologists. Seismic waves fields are recorded by a seismometer, hydrophone in water, or accelerometer based on acoustic energy. So the propagation velocity of the wave depends on the density and elasticity of the medium. Velocity tends to increase with the depth and ranges from approximately 2 to 8 kilometers in the earth crust up to 13 kilometers in the deep mantle. So classification of causes of earthquake based on the depth of the origin. Earthquakes are described as shallow or intermediate or deep. So earthquake with focuses less than 60 kilometers are called shallow earthquake. If the depth is more than 60 kilometers but less than 300 kilometers, they are called intermediate earthquake. Which the focus depth is more than 300 kilometers, they are called deep earthquake. This is common. This is a common part of the reporting, no, of an earthquake, no, in the Philippines. You will you usually hear the causes or the source of the earthquake, or if it is a shallow earthquake or a deep or intermediate earthquake. So because of the causes responsible for the occurrence, earthquakes are described as tectonic or non-tectonic. So tectonic earthquakes are exclusively due to integral causes, due to disturbances or adjustment of geological formations taking place in the Earth's interior. They are less frequent and more intensive, and hence more destructive in nature. No, because these are movements or adjustment of geological formations taking place in the Earth's interior. So these are not frequent events, no, but these are very destructive events, no. Or the non-tectonic earthquake, on the other hand, are generally due to external or surfacial causes. This type of earthquake is very frequent but minor in intensity and generally not destructive. So these are earthquakes that are not too destructive. No, these are the common earthquake that we usually experience. No, so an earthquake is a sudden and rapid shaking of the ground due to passage of vibration beneath caused by transient disturbances of elastic and gravitational equilibrium of rocks. No? The scientific study of earthquake is seismology. So earthquakes are measured using observation from seismometers, and seismic waves are recorded on instrument called seismographs. The time, location, and magnitude of an earthquake can be determined from the data recorded by seismograph stations. So in the Philippines, the agency uh, 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 made it a point to put seismographs, no, are very near earthquake fault lines, very near volcanoes, very near frequently occurrence of ground movement, so that they will have an history of the movement of the earth, or the geological movement of the surface or the ground or the subsurface of that particular area. So that is why we have a data on immediately on different areas that are having ground movement. So Richter magnitude scale, the Richter magnitude scale was developed in 1935 by Charles F. Richter. Earthquake with a magnitude about 2.0 or less are usually called micro earthquake, are generally recorded only on local seismographs. So there are a lot of micro earthquakes. If you are living near volcanoes like Taal, Mayon, no, Pinatubo, you are frequently experiencing, no, micro earthquakes, a magnitude about 2.0. Events with magnitudes about 4.5 or greater are strong enough to be recorded by a sensitive seismograph all over the world. No? So these 4.5 are strong earthquakes, no, that are recorded and be transmitted to datas on stations all over the world. No? Earthquakes have a great earthquake is a magnitude of greater than 8, no, or higher. On an average, one earthquake of a size occurs somewhere in the world each year. No? So 8.0 earthquake, no, occurs, no, once every year. No? But not only in the Philippines, but it may be on a different area of the world. No? So there are also man-made earthquakes. No? The impounding or large quantities of water behind dams disturb the crust balance. Shock waves through rocks set by underground testing of atom bombs or hydrogen bombs may be severe to cause earthquake. No? So if there is what you call a bomb or a an explosion, it may cause sudden movement of the ground. No? And another one is the large quantity of water behind dams disturbs the crust balance. So if there is a dam right beside your residence and the pressure of the dam to the wall surface may cause disturbance to the crust balance. So it may also cause minor earthquakes. So, the natural causes of earthquake, we have the tectonic movement, the volcanic activity, pressure of gases in the interior, landslide and avalanches, faulting and folding of the rocks beds are responsible for causing minor earthquake. So, destructive earthquakes, the effects of destructive earthquakes, this causes dismantling of buildings, bridges, and other structure near the epicenter. So, if you will experience a destructive earthquake, it may damage buildings and bridges. Rails are folded and underground wires are broken. Earthquakes originate sea waves are called tsunamis. So if there is an earthquake uh, on the sea, there will be a tsunami. Earthquake results from the formation of cracks and fissures on the ground, and earthquakes may cause landslide. Landslide due to earthquake may block valleys to form lakes. So now we will talk about the seismic belt. Uh, a narrow graphical zone of the Earth's surface along which most earthquake activity occurs. The outermost layer of the Earth, or the lithosphere, is made out of several large tectonic plates. There are three main seismic belts in the world. We have the Circum-Pacific Seismic Belt, the Alpine Himalayan Seismic Belt, and the Ridge Seismic Belt. We are in the Pacific Seismic Belt. We are included in the Pacific Seismic Belt because of the evidence of volcanoes in the Philippines. And seismic waves are waves of energy that travel through the earth layers and are the result of earthquakes, volcanic eruption, magma movement, large landslide, and large man-made explosion that gives out low-frequency acoustic energy. And these seismic waves are recorded by seismometer, hydrophone, or accelerometer. So P waves are type of body waves that travel through a continuum and the first wave from the earthquake to arrive at a seismograph. Typical values of a P wave velocity in an earthquake are in the range of 5 to 8 kilometers per second. So this is a P wave, So it travels about 5 to 8 kilometers per second. The S wave, secondary waves or shear waves, sometimes called elastic S waves, are type of elastic wave. The S waves move at a shear or transverse wave, so motion is perpendicular to the direction of the wave propagation. Velocity tends to increase with the depth and ranges from 2 to 8 kilometers in the Earth crust up to 13 kilometers in the deep mantle. So the L wave, is generally a type of earthquake which is called a surface wave. Reasons being is that the motion is restricted near to the ground and the ground surface. Such wave correspond to the ripple of water and travels across the lake. The range of velocities is between 2 to 6 kilometers per second. So this is a common type of wave, that are experiencing on the bodies of water or on the surface of the earth. So we have different precautions, in case that there are earthquake are frequent on your area. First is to do a soil test. This is the first thing that you will do before, if you feel that there is a need. If you feel that you will be building something that is more than 2 floors, you need to take a soil test. Structures will be constructed after testing the soil's compaction and tendency. So this is a basic requirement. If you will be building something more than 2 floors, make sure that you execute a soil test on the ground. Design of the structures or the building should be made by professional engineers. So this is one also of the a good a better and good way to design something is to hire a professional engineer to design your structure. Use rods accordingly to the foundation type. So you need to make sure that you are buying or procuring the particular rebars or rods that are specified on the plan. The rod must provide necessary earthquake resistance to the buildings or the structure, and maintain the quality of cement, rod, and sand. So you need to make sure that you have the right quality of cement, right quality of sand, and right quality of bars. provide necessary rod in the joint foundation and grade beam, and this helps to provide extra earthquake resistance to the structure or building. Check column and slab design requirements by the authority. So for earthquake resistance purposes, there will be no connection in the intersection of beam and column. Column, the structures of the building need to be made strong to provide resistance. Column size can be increased from the necessary from the foundation if necessary. So these are samples of a structural component of a building, no, showing the showing and addressing the possible earthquake or movement of the ground. No, so as you can see, there are flexible spread footing, and there are connecting beams connecting all the footings and the columns, and these are some of the solutions or remedies or enhancement for buildings, no, for to address earthquake or ground movement. They put cross bracings, as you can see. They put shear wall on the building. They put a shear core, the elevator shaft, which is a shear core, and they put moats and base isolator, okay, for in the building. So these are the cross bracing, no? Hydraulic cross bracing that addresses the movement of the building, no? The horizontal movement of the building. The landslide is the term refers to the downward sliding of a huge quantities of land masses. Often loose or unconsolidated superficial material undergoes sliding. Debris, rocks, slides, and rockfalls are important type of landslide. So the debris slides are failures of unconsolidated materials on the surface of rupture. Rock slides are movement of essentially consolidated material of recently detached bedrock. So these are different scenarios, no, of landslide. No, the causes of landslides because of water or rain, no, snow, glaciers melting, rising of groundwater, increase of hydrostatic pressures on cracks and fractures, loss of absence of vertical vegetative structures like soil nutrients or trees, no, after a wildfire or after a forest fire, erosion of a toe or a slope of rivers or ocean waves. So these are gravity. These are causes of landslide. No, gravity works more effectively on steeper slopes. No, you can see that if it's a steeper, no, the force, the occurrence of landslide, no, is likely to happen, no, because of the unstable and steep slope. No, because if it's a stable slope, no, the movement of this building may lessly occur. No? So these are common landslides. As you can see, the effects of landslide very near the street. No, if it falls down, it may cover the street or it may create accidents. No, these are also landslides on of a large. As you can see, there is a slip, no, or a of soil, no, or because of the landslide. Okay. So natural causes include the elevation of pore waters by saturation of sloping material, vibration caused by earthquake. So earthquake can also cause landslide, no, volcanic eruption, undercutting of cliffs and banks by waves of river erosion. So water can also cause the erosion of soil, like this in this case. No, if there is a water below, no, it may create a underground excavation at this area may loosen and then fall down. It also may also be caused by human, no, removal of vegetation. If you cut the trees above the mountain, no, it will cause erosion or landslide. Interference with the change of natural drainage. No, if you will remove natural rivers or natural water passageway, it may cause landslide. leaking pipe such as water and sewer recirculation, modification of slope by construction of roads, railways, and buildings. So if you alter the slopes, no, and you did not alter it properly, it may cause landslide later on. So the landslide hazards, although landslides are primarily associated with mountainous regions, they also occur in areas of generally low relief. No? In low relief areas, landslides occur as cut and fill failures, no? Like in the cutting and filling of the mountains. No? Slope saturation by water is primarily caused by that of landslide. This effect can occur in form of intense rainfall, snow melt, changes in groundwater levels. Mitigations of landslides. So vegetation covers protects lands from landslides and soil erosion. So planting more trees, no, will prevent, no, eventually prevent landslide. Provision should be made for community to level or prevent from excavating, removing material from the soil or cutting trees. Surface water should be diverted towards a natural gallery, enabling water to quickly drain away from the slope. So you need to return the the natural, no, arteries of water, no, on the land, so that it will prevent the erosion of the or soil erosion or landslide. So groundwater, an aquifer is a ground layer of water bearing permeable rocks or rock fractures or unconsolidated material. And the study of water flows in aquifers and characterization of aquifers. Aquifers occurs from near surface to the deep of 3,000 feet. Those closer to the surface are not more likely to be used for water supply and irrigation, but are also most likely to be topped up by local rainfall. It's called hydrology. So we will discuss further this groundwater on our next topic. No, we will discuss the water features of the site, the behaviors of water, and the possible solutions on how to manage the waters on the site. Okay, so that will be all for today.